Assalamualaikum warahmatullahi wabarakatuh. My name is Nursyahria Aqila Binti Ramli, and I'm gonna present to you presenting the coding for the person class, which refer to question 1A. This is the class person that need to have the information such as name, age, height, and weight. Here is to define a class consists of name, age, height, and weight. Then need to define each of the data itself, like define the name, define the age, height, and also define the weight. Okay, next is question 1B, which is you need to create a CSV file consists of the all information like name, height, weight, and age. And this is how the person.csv file looks like. And then to implement it as an object in the main method, we have to do the coding like this with open person as CSV file, which is to read CSV file. Refer to the question 1B, and then reader equal to csv.reader CSV file. That's how we get the information from the person CSV file. Next is the linked list, which refer to the question 1C. First, we have to make a class node that need to initialize the data of the linked list class node, and then we make class linked list, initialize the linked list itself, and then we define the constructor of append, which is to add the data, and then define the get data, which is to get the data to change from node into the array, and then define get item, which is we get the data to return itself, to implement the data, to get the data, to print out, to print the array. And then we need to declare list name as an object for linked list, which is this one, list equal to linked list. To declare list name as an object for linked list, which refer to question 1C. And then for row in reader means linked list with 20%, which we include the data from CSV file into linked list. Like we take all the information in this person CSV file, we change it. We get the person information through the linked list, like this list.append. And then question 1D is to print the linked list. Here is the command for print the linked list. The output it looks like this. All the information of the name, age, height, weight of a person consists of 20%. Next, for the binary question 2A, which is comparison between binary and linear search. What I can say is binary search how it's searching, the value itself is start from the middle of the shorted list, which is 23. And then to find the value that you want, it will go the nearest value, which is the greater than or the less than. So for example, if the midpoint is bigger than the value you want to search, the midpoint will get the -1, because for example the middle point is 23, what I want to find is 24, and then 23 is less than 24. If it is less than 24, it will get +1, so that it will get the bigger size than 23 to find the 24, which is the 24 lah. I get the 24. If the midpoint value is bigger than 24, which is like 25, it will -1, so that it will go left to find the value that less than the middle point and middle value, like that. Okay, so we print the result. That's how binary search performance working. Like, the performance is great even though the coding is complex, but it is better in search, so it doesn't waste time, like how the linear search work. So basically binary search are more efficient if you want to find something, so that you get the less time consumed. So we run the binary search. Yeah, the output we get element is present at index 11, which is 24. Okay, for the linear search, the code is very simple, but the searching for the value itself takes time, because it will go through one by one until it find the value that you want to find. Like, it will keep searching, such as 16 is not the value you want until 18, 19. It will keep on searching until you find the value that you want, 24. So you can see that it's harder to find, because the system itself will ask one by one, will search one by one until you get the exact number value itself. Like, if the list is more than 50, then the time consumed that you need to find is bigger lah. So that's how I see the difference in performance between binary search and linear search. So if you run the linear search, it's basically get the same output. Like this. And then for the tree, we need to define the init node, make a class node first, and then we need to insert the node data, which is if the data is more than the self data, it will go into the left, and if the data is bigger than the self data, it will go to the right. And then we print the tree, define print tree. And we made next is pre-order traversal. Pre-order traversal is to maneuver the movement of the given binary tree accordingly, which is from root we go left and right, and it also lists all the binary trees given, and this one is all the value in binary tree that we insert manually, and then we print the pre-order traversal, and then we make a class new node, which we insert a new data in the left or in the right, and then we need to find the maximum value in a given binary tree. It consists of three value, which is root data, and then maximum in left subtree, and then maximum in the right subtree. And then the driver code is how we print the output, which is we need to insert the value itself, and then in the according the manual tree that we have made, and then we print the maximum height, and it's also basically the same how it works with find minimum height in root. And so if you run the binary tree, you will get the output like this, the list of the binary tree, and then the maximum height is 1.8 and the minimum height is 1.5. That's conclude the question 2b binary tree. Thank you.